Welcome to Coruzant Technologies, home of the Digital Executive Podcast. Do you work in emerging tech, working on something innovative, maybe an entrepreneur? Apply to be a guest at www.coruzant.com/brand. Welcome to the Digital Executive. Today's guest is Charles Yeomans. Charles Yeomans is the co-founder and chief executive officer of Atombeam Technologies, bringing over 3 decades of executive leadership experience spanning investment banking, technology, private equity investment, and mergers and acquisitions. Throughout his career, he has led multiple organizations, including Trigamy and Portal Group Holdings, where he served both as president and CEO. A seasoned entrepreneur, Charles has successfully founded and scaled companies, including major insurance brokerages. Prior to his business career, he served as a U.S. Navy intelligence officer. He holds an AB from Kenyon College and an MBA from Stanford University. Well, good afternoon, Charles. Welcome to the show.
Same here, Brian. Glad to be here.
Absolutely, my friend. I appreciate it. And making the time, traverse 2 time zones. You're in San Francisco today. I'm in Kansas City. And that's a huge deal to me. You're not in my backyard or I'm in your backyard. So this is just, again, a heartfelt thanks to you for making this work. And Charles, if I could, I'm going to jump into your first question. You've had a diverse career spanning military intelligence, investment banking, private equity, and entrepreneurship. What experiences shaped your journey to becoming CEO and co-founder of Atombeam Technologies?
It's like many folks have had an interesting sort of like turn left, turn right, and you never really know that. Well, you do sometimes know that this is a big deal. I'm making a big change here, but a lot of times you don't. Like one of them was like when I was in the Navy, I was doing really well. I was a briefer. I went over to the White House for intelligence briefings and that I gave and so forth. And it was a great experience. And then I said, I always planned to go to business school after that, but it got to be a very difficult decision. And I said, okay, I'm only going to go if I get into Stanford or Harvard. And I got into Stanford and I sort of just decided, okay, that is what I committed to do. So I'm doing it. But it's one of those things. And another was leaving investment banking and going to be an entrepreneur. Just started to feel like, okay, I'm not cut out to I'm too restless. I have to think about things too hard. I get fascinated by technology. And so I just really started drilling down and doing things. And that turned out to be the right choice for me. And I've ever since then been, after I left banking, investment banking, I'd become an entrepreneur, had private equity backed companies I ended up being CEO of, and as well as other companies that were startups of various kinds. So it's an interesting thing. And if you love to learn about new things and you feel strongly that you have a vision for how things work, I mean, this is the life for me.
Thank you. Really appreciate that. And I like your commitment. You're steadfast. You had a diverse career. You were curious about your career and you had a great one from your military, including the White House. But whatever you did, the message I took away, you were determined and committed to whatever career education you set your eyes on. And I thought that was interesting. And again, very diverse. But the last thing I'll say here, just to highlight what you said, is you just really love to learn about new things and you went after it. And I know there was a lot of hard work behind that. We all get that as entrepreneurs, but I really appreciate the backstory of where you started and where you ended up. And Charles, Atombeam is focused on transforming how data is processed and transmitted. What core problem in today's data infrastructure inspired the company's creation?
So that is a really interesting point. It's like the fastest growing category of data is the data that machines generate, usually called IoT data, Internet of Things data. But that includes a really, really big chunk of the data that's out there. And it is the fastest growing. And it'll even be by 2030, the expectation is it will be bigger, the biggest category, even bigger than video. And that's because there's so much of it. I mean, you think about think about a car. It used to be a car would even not send any data, then send a little bit once a day. And now it's like the cars generate 25 gigabytes an hour. But the capacity of the network to send that is about 1%. And so very little moves, even though the car makers would like a lot more of it. But it's expensive to send it. There isn't that much capacity. And that's just one example. There's many, many. I mean, you take all the new ideas about being able to use a cell phone over directly on the satellite. That is going to overload the satellites, almost certainly, which means that you need a ton more capacity there than is really practical. And so when you boil it all down, there's tons of this machine-generated data inside of data centers, data moving around everywhere. And it is the fastest growing category, but it's also the capacity of networks to handle that is growing at about half the rate the data is. That means that the problem now is a lot of data just doesn't get it to where it needs to go. And so they end up sampling the data to say, okay, we want to make sure that this oil platform doesn't fail. And so, but it can handle about, I don't know, it's like maybe 2 or 3% of all the data that's generated, fairly typical. And that means things fail. So how do you make it better? How do you send more data over the same network without having to replace the whole network? I mean, you can't like go out and launch a bunch of satellites reasonably when they do, but doing that, and it is expensive compared to software. So our thinking was, okay, if we can generate a software that's, what it does is that it compacts, we use that word because it's different than compression, but it compacts a stream of data. In other words, it's not dependent on some pretty big file like compression is. And these messages that a machine generates are too small for compression. So what we do is we are swapping out the actual data for little keywords in a code book. And the consequence is we can send usually on average about 4 times more data through the same network, which means that in many cases, you don't have to replace your network. You just install what we call a product called Neurpac in that network, which means that that network is now has dramatically more capacity. Let's, for instance, like Ericsson, one of our partners. We did a webinar with them last week, and they're all over this. I mean, think about they make these things called gateways, which are a way of collecting data from a bunch of sensors and then sending it on to the cloud or somewhere. And what's the point? The point is to send data. Well, if you're Ericsson and you install Neurpac, you can send 4 times more data through the same bit of hardware. So that makes it a better gateway. And so we can address all this stuff with our Neurpac product and literally transform the world in how much data moves. It's by changing the fundamental basis of how data is still very usable, readable, but it's way smaller. And that changes everything in the world. It's a fundamental thing.
That's awesome. Thank you for sharing. And I didn't know the fastest growing category of data is that data being created by or machine learning. And you said it estimated to grow bigger than video in the future, which, gosh, we know video is just massive. So this is interesting. Yeah. So thank you. And the capacity of these networks obviously just cannot keep up. Typical network, you said it's only growing, the technology is only growing at half the speed that the data is being generated, which is going to create an issue. But thankfully, your platform Neurpac can send up to 4 times more data through your typical network. And again, you're solving a big gap here, really to make the world a better place. And I appreciate that. So Charles, if we switch gears, data efficiency, let's go a little bit deeper into this, and optimization are becoming critical as AI and connected devices scale. How does Atombeam's technology help organizations handle increasing data demands more effectively?
Well, it's a lot of it. So part of it is like what we were just talking about, but being able to say, without having to, like let's take Viasat, one of our partners, their satellites cost about $500 million each. They're geosynchronous, big honking satellites. And those things are are tough to go up and say, okay, this is not like a Leo thing on Starlink. You got a serious piece of iron out there, and you can't just sort of swap it out, or you can't like drive up and upgrade the hardware on it. So now you can suddenly, with a bit of software, that instead of launching 2 or 3 more satellites to add to your network, if you're Viasat, you can just use Neurpac. So it's a massive impact on this thing. The other thing I want to mention here is LLMs. So you think about LLMs and how they scale, which is badly. And the reason they do is because fundamentally they never learn anything. What they are is they're trained. And then once they're trained, they are deployed and people can use them. But the problem is that once they're trained, the weights, which is what is the inside of these massive transformers, are frozen. They absorb basically all the information in the world. And then after that, they stop learning. They can't learn anything new. And so what that means is when I ask an LLM a question, like, what is a golden retriever? It'll go through the same process the first time I ask it, the second, the third, and the millionth time, so that when you get to a point, at which you say, all right, I've got to know more than this thing. No, this thing should already understand this. It should not have to do every single computational step because it should know what a golden retriever is. And so our new AI, which we call the persistent cognitive machine, or PCM, is a totally different architecture. And instead of the approach that an LLM uses with transformers, it uses a different fundamental basis. And that allows it to learn and to be able to, by learning, become way more efficient. The first time it learns what a golden retriever is, it goes through a process. And it isn't as giant and inefficient as an LLM, but it's big. It's still not as efficient as it would be the second time, the third time you ask. It's like a human brain. We don't have to be told literally millions of times what a golden retriever is. Look at millions of pictures. It knows. We learn after a couple times and then a few more times, and it gets better and better. PCM is the same thing. It becomes more efficient. The other thing is there's an enormous need out there for no hallucinations. Hallucinations is a huge problem. And for instance, like we're talking to DARPA right now. DARPA is very keen on our AI. The reason is they can't have hallucinations. Zero. I mean, you can't make a mistake and fire a missile at a cruiser and a cruise ship or something. I mean, you can't do anything wrong. And so our PCM has 5 checks to say, is this real? Is it right? Is it true? And not only that, it goes beyond an LLM. An LLM is, instead of like with an LLM, it's statistically predicting what the next word is. And it has context and it's enormously powerful. I mean, I'm not denigrating LLMs here, but they fundamentally are predicting the next word, which means that if I go, the dog ate and ask it to fill in, probably whatever it is, 60% of the time, it'll say dog food. But maybe 1% of the time, it'll say the little boy. And so when it zooms off in a direction, then you can end up with all this stuff that's totally wrong. And so it has no cognitive understanding, whereas the PCM is on the basis of its architecture, just like our brains do. It really understands what the dog ate, what the dog is likely to be eating within a reasonable. It's not going to say the dog ate the house or some completely wrong thing. It's going to know that's not right. And so and there's some other things about it that are absolutely critically important to understand to have in future AI. Our AI doesn't need a data center even. It's dramatically more efficient. And so I think what we're going to find here is it's going to evolve that architecture. I mean, we have 207 patents on this architecture. Not all of them are issued, but we have a lot of patents. And we think, and so does DARPA, that our approach is the way of the future. So it's going to change a lot of things, because right now the inefficiency of LLMs is just over the top. It's crazy. We are running out of power. We're running out of water, and we can make as many GPUs as you want, but if you can't power them, that's a problem. And the Chinese have all the power they need. The U.S. does not, and it's going to be. It's good, and there's already some dark data centers that have never been turned on, and it's going to be more and more of that. And so something needs to give, and we think that the PCN is what that thing is.
That's awesome. Thank you. You brought up several examples. Obviously, the satellites, the LLMs. You really dove deep into that, and I appreciate you unpacking that for our audience. That software of yours obviously provides a lot of solutions, but your AI, and you've got some patents there, your PCM technology allows the LLM to continue to learn and become way more efficient, obviously safer. We don't like hallucinations. We talked about this a lot on the podcast. So I appreciate all the insights there of what you're doing and making a better, safer world with this new AI. And Charles, the last question of the day, as we look to the future, how do you see the future of data transmission, AI, and global connectivity evolving? And what role will companies like Atombeam play in shaping that future?
Well, I think it's pretty well understood that most of the best innovation comes out of little companies. And there's a reason for that. It's where in small organizations, I mean, like DARPA invented the internet, right? So if you think about like where Atombeam plays and where companies like Atombeam play, it's really, we're outside the four walls of big companies. And big companies come up with great stuff, and I'm not arguing that they don't. And some of them are incredible. And they have infinite resources in many cases, effectively. But we think that we are going to, that some of the really best stuff, and it isn't just me thinking this is true. Much of the best stuff comes from the little companies who are entrepreneurs that some guy has a great idea. He sees an opportunity. He sees a chance to make a lot of money. He sees a chance to really change the world. And that is what we think we're about. We know we're about. And you get things like going on like our PCN. I mean, it's not invented by, like, Google has, I think it's 35,000 PhDs. I mean, but we invented it. Yeah, we've got some PhDs too, but a lot fewer than 35,000. And at the same time, you look at the need is coming. I mean, Anthropic, their uptime just went below 99%. And OpenAI, they killed their video product, their Sora, because they needed more GPU time for coding tools. And GPU rental prices, they've almost gone up 50% in the last couple of months. So there is an enormous issue going on here with the need for somebody to come up with something new here. It's unsustainable. And so the little companies like Atombeam are the ones that I think are, not that the big companies aren't coming up with stuff too, but some of the best stuff is coming from the little companies. And the little companies who are driving that innovation are, I think, it's a tough environment. These big companies, are tough players, but we think that we have something, and we've thought through it very carefully, and we've put in a lot of patents for it. We have over 500 patents total. And all of that is massively important when it comes to where we're going, how we can, as a small company, impact things, and how other little companies can impact things. You don't go into this game and without your eyes open, but if you can go into it and be a real player, and that's what we are.
That's awesome. Thank you so much. Really appreciate that. And the big takeaway here, Charles, is, as you said, most of the best of innovation comes out of small companies. Passionate entrepreneurs, obviously, they have small teams. They can pivot on a dime. They have a vision. They're excited. They're enthusiastic. And don't get me wrong, big companies can still produce good products, right? But typically because of their deep pockets, that's generally and the large resources that they have at their fingertips. So I really appreciate the insights today. And Charles, it was such a pleasure having you on, and I look forward to speaking with you real soon.
Well, same here, Brian. I really appreciate you having me. Have a good week.
Thank you. Bye for now.